Hello, I'm Dennis O'Donnell, and today I'm going to be doing a demo video. We're going to demo the model ZM-R730A, and over here on the right, we're going to demo the model ZM-R730A. We'll be reworking some connectors and some BGA components. And so to start, I just want to explain a little bit difference of the two models. This is a larger machine, the ZM-R730A on the left here. It's a larger machine. It will do larger boards, and it will do larger components. They both will do very small components. The biggest difference is on this machine you have a robotic head that moves around and it makes it easier to place large components, say over 40 millimeter. On this machine, once you start getting over 40 millimeter, it gets a little tricky, and if you have components that don't have like solder balls in the center of the component, it's just a little bit trickier to align the components. So I would say the 730A has limitations. Once you're getting over 50 millimeter components, then you're going to be limited. And I'll just show you a quick example here. So what I have is this is a 52 millimeter component. Let me put it on the board. I'm just going to select our sequence. It goes over here and centers in the nest. You don't have a nozzle on, so you can see everything's functioning. And I'm just going to press confirm, and it'll pick up our component automatically. So once we have the component here in the screen, we can zoom in, zoom out, and we can see the whole component. But when we're lining it up, we may want to zoom in and focus on one corner. So let me go here and do some lines. So I'm just going to move this over here to the corner, and we'll zoom in. So what this will do is we can move the camera to any corner of the component, around the perimeter of the component. We can zoom in. We can zoom in really close. And so it makes it easier to line the corners of the components to the pad. On this machine here, it's a stationary rigid system. Once you pull it out, you just look straight down at the component. So I'm going to be lining the balls to the pads using this vision system only. I can't move it around to the corners of the chip or the perimeter of the chip to look at larger components. And we'll do a lot of physical demo on both of these later on in the video here. But for right now, what we're going to do is we're going to focus on doing a demo to remove the connectors. We're just going to stop this. And currently I have the board in here, and we're going to remove this style connector. With these ones, for this video, I'm going to do a manual removal. We're going to do automatic heat. So if we do a manual removal, we're not going to need the pickup tubes. So what happens is these have different size pickup tubes, and they screw or unscrew inside the pickup tube shaft. So for this demo, we won't need that. We will need a heater nozzle. And I've already got the board set up in here using some of the tooling. And I put a thermocouple here underneath the connector, so we can tell when it's getting close to reflow temperature. Because this is the first time we're doing this. I just made a generic profile that's programmed in the machine now. We're going to see where this melts, and then we'll reset the profile for this particular connector. So what I want to do, I'm going to change my mode to a heating mode. They call it Will. I'll just press the start button. It's going to go over here. We got to zoom out. And what this does is it's got a split vision prism, and it looks at the circuit board and it looks at the component at the same time. And we can adjust the lighting to differentiate between the two. So right now I'm just going to turn the bottom lighting up so we can see the component here. And I'll turn the nozzle up and we'll see the nozzle. So the board light is more of a yellowish color, and the nozzle here is a blue light. I'm going to bring this down a little bit to make sure it's centered. And so I can see the component centered between the nozzle here. Just my line in a little bit. Make sure my nozzle is straight. And I already centered it earlier for the vertical. So all we have to do is press confirm. The nozzle is going to come down. And once it gets close to the chip, it goes into a slow speed. Now it's going to run the heating cycle. So we have a top hot air and we have bottom hot air. The nozzles are magnetic, so they just stick on magnetically. And so while this is running, we'll go through some of the other features. I'm going to turn my light here, and we can switch over here. And this switches between the cameras. So we have a side view camera here, and we can see when the solder is melting. So when we remove it, we can see when the solder is liquidous, and when we install it, we can see when the solder refills. We can see our solder balls right here. I know you can't see right here right now because I put some flux in there to help transfer the heat. And so that's going to run, it's going to be probably about a 5-minute profile before it heats up. So we can talk a little bit more about the machines. So this machine is all touchscreen controlled. It has a 10-inch touchscreen, it's a little bit larger. This machine over here, it's touchscreen controlled also, but it just has a 7-inch, so it's got a smaller touchscreen. This one has top hot air, bottom hot air, and then it's got an area heater for preheating the board. And these are called ceramic type area heaters, just a standard, the breeders are just standard ceramic. This one here has a rapid heat area heater, which heats up much hotter and distributes the heat more evenly and faster, so they call it a rapid heat. And the rapid heat is good if you're going to be doing large or thick boards, and if you need the preheating, it helps preheat the boards. And if you can preheat the boards, then you can use less top and bottom hot air. Another feature on this is the bottom nozzle over here moves up and down, so we can adjust how close it is to the board. Now you can keep them about 1/8 of an inch to 1/4 inch from the board. I don't have them touching the board when it's running. And so right now we're just going to wait to get to liquidus, and then we'll come back and take a look at what's going on. Okay, so we're at liquidus now. We can see the solder is melted across the chip. We can note our temperature that we're going to set it when we come back and finalize the profile. And now I'm just going to get ready to take the nozzle off, to take it off manually. So I'm just going to go back here. I'm going to turn on my manual operation. I'm just going to move this up. Okay. Let's take that off there. Let's move it, set it down here. And we'll just stop the machine. And it's going to go into cooling mode. And what we're going to do, we're going to clean up the board, we'll put solder paste on it, and get ready to put the component back on. Okay, so what we do when we're doing these SEM style connectors with the little solder tabs on them, is some people use solder paste. They just paste the board and they put the connector on. What we do is we paste the board, and then we're going to reflow the solder paste to the board, and we're going to install the connector with tacky flux. So what that does is it'll solder bump the board, and it'll increase our yield. It'll reduce the chances of having opens and also of shorting from putting it on with a wet solder paste. So right now I've got the side view camera close up. You can see all our solder paste here. So we're just waiting for it to come to reflow temp, and then we can watch it reflow on the side view camera. As we can see, it's starting to reflow now. Reflow on the front. I'm just going to go to the back. A few more back here to heat up, just wait for it to heat. Last one. So it's got complete reflow. I'm going to let it run for about a 30-second soak, and then we'll stop the machine and we'll get ready to put the component back on. So we can see here we have some nice even solder bumps. And what this will do, these type of connectors, when you use solder paste, the tabs sometimes they tend not to wet and without open. So if we use bumps with a Tacuflex, we'll find we reduce the chance of having solder opens. Okay, so we're at our next step. So, you could pick and place this and use the camera and line it up and place it with the machine, but with these type of connectors, they have guide pins, and then it's bumped instead of solder paste. We don't have to worry about smearing the paste. So it's just real quick on these ones. You just go ahead and just put it on here. Hit it in the guide pins. You can look in your side view camera here. Give you a little focus. Get my side view camera. There's a little play left and right. I'll just make sure that they're on center there, and it's ready to run. So it's already lined up because we're using the tooling fixture. So every time I take this board in and out, it's in the same position. So I don't have to go through and realign it and the nozzle and everything again. So when we're doing a lot of these, we can just do one after another and don't have to worry about doing the whole alignment sequence. So I'm just going to change this our sequence here, and later on I'll do a little touchscreen video. So I'm just changing my sequence to weld. I'm going to press start. And also, this is optional. You can turn this feature off. If you don't want the camera to come out every time, we can turn it off and we'll go right to reflow. But for now, I'm just bringing the camera out. Nozzle's going down. And you have manual operation, so if I would like to move it down a little more, I can on the manual operation. And basically, you can set the machine what height you want it to stop at. But that's good. So it's going to be about another probably 5 minutes, and then we'll hit reflow cycle. So I'll come back and we'll watch it reflow. Okay, we're getting approaching reflow temperature now. You can see it's starting to reflow over here. It's like the outsides are starting to reflow first, and then it'll reflow in towards the center. It just went down. You can saw it compress. You see it went down to the board here. So we're at complete reflow now. We'll just note the temperature. We're on 240. We'll give it 30 seconds, and we'll be done.